Hello, welcome to our live class for today. In today's live class, we'll be looking at this Harvard entrance test examination. And we are asked to find the value of x in x to the power of negative 2 equal to negative x to the power of 2. This can be a startling equation. This can be a startling question to a lot of persons who might not know how to go about solving questions like this. But then, how can we find the value of x? Now, to find the value of x using indices, we can find out that this can simply be equal to 1 divided by x squared, and this can simply be equal to negative x squared. Now, what do we do from here? From here, what I will simply want to do is to multiply both sides by x squared. Now, what's the essence of multiplying both sides by x squared? So as to simplify. Now, if I multiply both sides by x squared, the left-hand side, which is this side, will be reduced to 1. Now, let's see that. That will give me x squared multiplied by 1 divided by x squared, and this will be equal to negative x squared multiplied by x what? X squared. Now, while this cancel out this, we'll be left with 1, and this will be equal to negative x to the power of, according to indices, this will add, we will have 2 plus 2, and that will be equal to 4, and that will be 2 negative x to the power of 4. Now, how can we play around with this negative sign? Can we easily find the value of x from here? These are big questions that are looking for serious answers. Now, how do we solve this question? Now, I have to clear this negative sign because it's a very big obstacle and I have to take it off. Now, what do I do to take off this negative sign? I'll have to divide both sides by negative 1. Now, if I divide both sides by negative 1, what do I have? Negative here will cancel out negative, and then this other end remain negative 1, and this will be equal to x to the power of 4. Now, what do we do from here? I guess we can equate the equation to 0. Now, if we equate the equation to 0, this will give us x to the power of 4 plus 1 equal to 0. Now, we have a very good expression that can bring about a very good algebraic expression that we can expand in order to solve for x. Now, at this point, what do we do? This is a tricky one indeed, and then we'll be left with what actually we need to do. We need to factorize. Of course, it's an algebraic expression, and we have to factorize. Now, what if to factorize, I decide to add x to the power of 4 plus 1, and then I add 2x squared, subtracting 2x squared, and make this equal to 0. I've not changed anything. Now, from this expression, you'll find out that we totally did not change anything. Now, if I take out this expression, I can easily simplify it. Now, if I simplify that expression considering algebraic expression or algebraic formula, this expression can give me x squared all square, representing this, right, plus 2 multiplied by this x square multiplied by 1, and this will be plus 1 square, right, and this will be minus 2x squared, and this will be equal to 0, this negative 2x squared. Now, if you look at this expression very well, which is an algebraic formula or algebraic expression, you find out that this is equivalent to a square plus 2ab, right, plus b square, and this is equal to, remember, a plus b all squared. And that is an algebraic expression. So if this expression is equivalent to this, that means this represents this whole thing represents this, while this represents b. So that means I can simply replace this whole expression to this form. Very easy to crack. Now if we look at that form very well, you find out that we'll have this to become x squared, right? That will give us x squared plus 1 all squared, right? Minus, which is negative 2x squared, while this becomes 0. Now what do we do from here? All we simply need to do is to simplify this expression so that we can simply have a definite solution. So what I'll do is, let's clean up this and then let's see how we can simplify that expression. Now to simplify this expression, I will simply have to bring this, and this expression, in order to clear off the square or to make it look like an algebraic expression, I will have to simply take the square of this side. Now, the reason why I'm taking the square of this side is to still give me the value of 2. Now, look at what I will do there. I will simply have this to become x squared plus 1, right? All squared, and this would be negative square root of 2x all squared. Now I haven't changed anything. If you find out, you see I haven't changed anything, because if square cancel out the square root, I'll still be left with what? Negative 2x. So that expression will still be equal to 0. Now, I'm only mindful because I want this expression to give me a situation where I will have a diff of 2 squares. Now remember, if I have a diff of 2 squares, a minus b, this can simply be equal to a plus b, and then a minus b, right? And that's exactly the expression where I'm truly heading to. Now, if you have this expression, you can easily simplify. Remember, from this expression, you can see that a is equal to x squared plus 1, and then b is equal to the square root of 2x. So I can easily expand that, and if I expand that, I'll have that expression to give me, the first part of that expression will give me x squared plus 1, and that will give me what? Plus square root of 2x, right? That will be the first part of the expression, and then I'll have x squared plus 1 minus the square root of 2x, and all of these will be equal to 0. So those are the two expressions I'm going to have from this expression. Now what do I have to do? I have to simplify those two expressions in order to get the value of x. Now we simply have to look for the value of x from those two expressions. Now these two expressions simply look like a quadratic expression, so I'm going to take this as expression 1 and then take this as expression 2. Both of them can be solved quadratically in order to get the values of our x. Now remember, our main aim is to find the value of x. Now let's take the first part, which is the positive part. If we take the positive part, we're going to have this expression to now give us, this expression is going to give us, good. So that is fine. We have this positive side. We're going to look at each of these sides and then see what the solution is going to give us. Now let's look at taking this first part. If we take this first part and rearrange it, we're going to have x squared plus the square root of 2x plus 1 equal to 0. Now if we compare it with this expression, ax squared plus bx plus c equal to 0. Now you find out that your a is equal to 1, and then our b is equal to square root of 2, and then our c is equal to what? 1. When we have this expression this way, all we need to do is just simply to simplify using the quadratic formula. Now if we use the quadratic formula, we call the quadratic formula, the value of our x will be equal to negative b plus or minus the square root of b squared minus 4ac, and all of these will be divided by 2a. Now if we use this expression to simplify this, we are going to accurately get the solution. Now let's insert all these expression, all these parameters into this. The value of our x will be equal to negative square root of 2 plus or minus the square root of 2 all squared minus 4 multiplied by 1 multiplied by 1, right? And all of these will be divided by 2 multiplied by 1. So if we have that expression is going to give us the value of our x to be equal to negative square root of 2 plus or minus. This is going to cancel out this, and then we'll have that expression to give us 2, and this will give us the square root of 2 minus 4 times 1 is going to give us 4, and all of these will be divided by 2. So what do we have there? The value of our x will be equal to negative square root of 2 plus or minus the square root of negative 2, and all of these will be divided by 2. Now what do we do from here? We're going to have the value of our x to be equal to negative square root of 2 plus or minus. This is going to give us I square root of 2, right? All divided by 2. Now if we simplify that, expression, we'll have our x to be equal to negative square root of 2 divided by 2 plus or minus I square root of 2, remember the conjugate, divided by 2. So this is absolutely a solution. This is absolutely one of the value of x. So the value of x will have one of the value of x for that expression. The value of x will be equal to negative square root of 2 divided by 2 plus or minus j square root of 2 divided by 2, and this is one of the solution to that expression. Now we can get the second solution by simplifying the second part of the quadratic equation. Now let's look at how we can simplify the second part of this quadratic equation. If we simplify the second part of the quadratic equation, which is just similar to the first one, if not for the negative sign over here. Now if we have this negative sign over here, we can simply walk alongside that. So if we rearrange that, we're going to have x squared minus square root of 2x plus 1 equal to 0. Now if you are following us the way we are solving this hard entrance exam test, give us your thumbs up and make sure you subscribe to our channel for more of such solutions. Now if we have this, all we need to do is to apply the quadratic formula. Now what do we need to do? Apply the quadratic formula. If we apply the quadratic formula, we'll have our x to be equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. Now remember, from this expression, our a is equal to 1, our b is equal to negative square root of x of 2, and then our c is equal to 1. So if we substitute those expression, those parameters into this, we're going to have the value of our x to be equal to negative, right? Negative minus square root of 2 plus or minus square root of, we'll have negative square root of 2 all squared minus 4 multiplied by 1 multiplied by 1, and all of this will be equal to 2 multiplied by 1. So what do we do from that part? From that part, you find out that this expression, negative will cancel out negative, negative multiply negative will give us positive, and that will give us positive square root of 2 plus or minus. This is going to, since this is even, the negative becomes positive, right? The negative becomes positive. And if the negative becomes positive, so we're going to have 2. So we'll have the square root of 2 minus 4 divided by 2. So the value of our x will be equal to the square root of 2 plus or minus square root of negative 2, because 2 minus 4 is going to give us negative 2. So we'll have this to be equal to 2. So what do we do from here? Definitely we're heading to having our second solution. This is going to give us the square root of 2 plus or minus square root of 2 multiplied by the square root of negative 1, which will definitely give birth to a conjugate I. So if we simplify that, we'll have our x to be equal to the square root of 2 plus or minus I square root of 2 divided by 2. So the second solution, x, will be equal to square root of 2 divided by 2 plus or minus I square root of 2 divided by 2. And this is the second solution to that mass expression. So that means this question definitely has 4 complex solutions. They are all complex solutions, and the 4 complex solutions are negative square root of 2 divided by 2 plus I square root of 2 divided by 2, and negative square root of 2 divided by 2 minus I square root of 2 divided by 2. And you come over here, we'll have this to become square root of 2 divided by 2 plus I square root of 2 divided by 2, and then we'll have square root of 2 divided by 2 minus I square root of 2 divided by 2. And that is the 4 solutions we'll have for this complex what? For this complex number. Now, this is exactly the solutions we can get from this Harvard entrance exam question. Now, join us tomorrow as we'll be taking an interesting question on our live class for tomorrow. An interesting question, and this is an interesting Olympiad exam question. And what is that? If you are given 1 divided by a positive plus 1 divided by p, and you are told that this is 1 divided by 7, I want you to find the value of a plus b, all real values of a plus b from this equation given to us. Now remember, I told you, I said this is an Olympiad maths question. I want you to try it out, and don't forget to join us on our live class tomorrow, same time, as we'll be looking at the solution to this question. If you enjoy watching this live class, don't forget to give it a thumbs up, share it with friends and colleagues, and don't forget to subscribe to our channel for more of this live content. Thanks so much for watching, and bye bye for now.